Good evening, everyone. This is your third week for the problem solving session related to structural analysis tools. Uh, what we generally do in these sessions, we solve the problems related to topics what you have covered in the current week. Let me share my screen first. So this is your third week related to structural analysis tools. What we have covered in the previous 2 weeks is regarding to calculation of shear force diagram and the bending moment diagram for different types of beams. We have seen that how we can calculate static and kinematic indeterminacy for beams as well as for trusses. Then we have seen in the previous week that how can we solve the problems related to trusses using method of joints as well as method of sections. So let me give you a brief overview about the course. So this is the course which is divided into 2 sections, in which first section will cover the statically determinate truss, and the second section will cover analysis of statically indeterminate truss. So by this time, you must be knowing the difference between the statically determinate as well as indeterminate structures. So we need an additional information to solve the problem when it is required to deal with statically indeterminate structures. So that we will see after week 6. So till week 5, we will be dealing with different problems related to beams, frames that will you will be doing in the coming weeks. And what we have covered till current week, we have solved the problems related to trusses. So in trusses, what we have seen, truss is a two-force member in which bending moment is always equal to 0. But in actual site conditions, bending moment will come, but the amount of axial force that is coming in the truss member is very much more compared to the bending moment that we observantly observe. That's why we consider the bending moment coming in the truss member to be equal to 0. Why bending moment is coming in truss members also? Because the in actual conditions, it is not connected with other member as just a point force member. It is a planar section which is connected to other section, so in which the eccentricities of different joints will come into picture, and they will interplay with among themselves and then provide little bit of bending moment to the structure. But in journal, what happens that the amount of axial force is very high. So that's why we in the analysis we consider only the axial force coming in the truss members, not the bending moment. So bending moment we consider to be equal to 0. So that's the difference between the frame as well as the truss. So in frames you have shear force, bending moment coming into picture, whereas in truss members you don't have bending moment in the analysis. So what you have solved in the week 3, you have seen the problems related to trusses, in which you have seen that if you are required to calculate the deflections in the truss member, how you will solve? You will utilize the principle of virtual work. So what principle of virtual does is that it states that the total force or the total work done by the structure without the application of external force is equal to 0. This is the basic definitions of principle of virtual work. So for what purpose it is used? it is used to calculate the slope and deflection at different points of the member. So in journal, we say that work external or work done will be equal to external load multiplied by the displacement due to this external load, which will be equal to internal load multiplied by the displacement of internal member. Okay. So this is the principle we utilize to calculate the slope and deflection at different joints. Okay. I will not exactly solve the problems or you give you derivation because that you have already covered in this current week. We will just see which notations or formulas you are required to calculate the problem related to trusses. So in trusses, if you are expected to calculate the deflection at any point, how you will calculate? So suppose deflection I am required to calculate, you will take sum of n into capital N L upon AE, where n is the force in truss member due to unit load. Capital N is the force in truss member due to external force. L is the length of the member. A is the cross-sectional area. And finally, E is the Young modulus of the material utilized. Okay, so I am not going to derive this formula. So for this current problem solving session, you will see that we will calculate the deflection at different members utilizing this principle of virtual work. And from this principle of virtual work, we got this formula and we will use that to determine various horizontal as well as the vertical deflection at various joints of the truss members. So let's start this current session. So we will solve the problems related to trusses. So first questions tell you that you have to determine the member forces in the truss. So let me give you a brief overview of how you will be solving the problem. Okay. So for determining, let me go first. I don't know how it came here. So for determining deflections, your first step will be to determine all the external forces in the truss member. Okay, so first you will determine all the external force in the truss member. Step 2, remove all the external forces and apply unit load where deflection is required to be calculated. Okay, so now after applying this unit load, then calculate all the internal forces in truss member due to this unit load. Okay, then utilizing principle of virtual work, we will use the formula that we have written previously, that delta will be equal to NNL upon AE, and that will give you the deflection at that particular point. Okay, so this is what we will be covering in this whole session. Okay, so all the questions will be based upon this algorithm, and step by step we will solve each problem related to that using all these steps. Okay, so let's start first problem. So in the first problem, you are expected to calculate the member forces in member AB, BC, and AC. Okay, so this we have seen in previous session also, that how can we determine? We can determine using method of joints. So we will first calculate the reactions. So since this is a hinge joint, so two reactions will come. One is horizontal and one is vertical. Whereas at A joint, one horizontal reaction will come. So this will be HC, VC, and this will be HA. Now apply equations of equilibrium. Summation of horizontal force is equal to 0. That will give you HC plus HA to be equal to 0. Now you apply summation of vertical forces to be equal to 0. That will give you VC to be equal to 80 kilonewton. Okay. Now we will take third equation, that is moment about a point, that is moment about MC will be equal to 0. Now take all the clockwise moments to be positive, that is 80 into 4, and all the anti-clockwise moments to be negative, that is minus HA into 6 to be equal to 0. So from this you will get HA equal to 53.33 kilonewton. Fine. So this also will give us HC equal to minus 53.33 kilonewton. Fine. Now we have calculated all the external reactions. Now let's solve all the forces in the members. So first we will determine what will be the theta. Okay, so let's suppose this is theta. So we will determine tan theta to be equal to 4 upon 3. This will give you theta equal to tan inverse 4 by 3. If you solve that, you will get theta equal to 53.13 degrees. Fine. Now theta also we have calculated. Now let's start taking each and every joint and then solve the problem. So using method of joints, We will start with joint A. So first draw the free body diagram of joint A. So if this is your joint A, this will be FAC. This would be FAB. One horizontal reaction is also there, HA. And what is the value of that? It is 53.33. Okay, this theta also we have calculated. Now we will take summation of horizontal forces to be equal to 0. So summation of horizontal forces to be equal to 0. This will give you FAB sine theta plus 53.33 equal to 0. From this, you can calculate FAB equal to minus 53.33 divided by sine theta value. If you substitute, it will come out to be 0.8. From this, we will get FAB equal to minus 66.6625 kilonewton. Okay. So first force we have calculated. Now we will utilize summation of vertical forces to be equal to 0. That will give you FAC plus FAB cos theta to be equal to 0. This will give you FAC equal to minus, and minus minus will become positive. So 66.25 cos theta, and from this you will get FAC equal to 40 kilonewton. Okay, so now you have calculated two forces and one force is pending. We will utilize another joint, that is joint B. Now if we start with joint B, we will draw the free body diagram of joint B. What we will get? So if this is B, this will become FBC. This will become FBA. Okay. So let's divide it in vertical plane. So if your internal angle there was theta this side, and then this become theta here. Similarly, on the other side, this will become your theta. Same theta that you have already calculated. Okay. Now you know FAB. What is the value? It is minus 66.6625 kilonewton. And you require only the value of FBC. Okay. So how we will do? We'll take summation of vertical forces to be equal to 0. So let's take summation of vertical forces to be equal to 0. This will give you FBC cos theta to be equal to FBA cos theta. This implies your FBC will be equal to FBA, and it will become equal to one force I have missed, that is 80 kilonewton. So here 80 kilonewton will also be there. Okay. Then if I am trying to solve the problem, then what it will become? FBC cos theta will be equal to FBA cos theta plus 80. It will give you FBC equal to minus 66.6625 cos theta plus 80 divided by cos theta. So if you solve this, you will get FBC equal to 66.6625 kilonewton. Okay. Now, three members are there, and we have calculated all the three forces in the structure. So, next question tells you have to find the horizontal displacement. Okay. Now, it is expecting you to calculate the horizontal displacement at joint B using unit load method. So, it is also telling you how to solve the problem. It is telling you place a unit load in the rightward direction of joint B and then calculate the member forces in AB, BC and AC. Okay. So what we will do now, we will remove all the forces, and what we will do, we will apply unit load at joint B. Okay. So here we have to find the horizontal displacement. So we will apply horizontal load at joint B. Okay. So we will apply 1 kilonewton node here. Okay. So this is our joint A, joint B, joint C. We will again determine the vertical and the horizontal reactions in this case also. So this will become HC, VC, HA. Okay. Now solve this problem. What we will get? Take summation of vertical forces to be equal to 0. This will give you VC equal to 0. If you take summation of horizontal forces to be equal to 0, you will get VA plus VC equal to -1. Now you take summation of you will take moment about any point equal to 0. Let's say I am taking point C. What you will get? So anti-clockwise is negative. So -1 into 3 minus HA into 6 is equal to 0. This will give you HA equal to -1/2. Fine. Similarly, we will calculate HC, which will become -1 plus 1/2 equal to -1/2. Fine. So all the external reactions now we have calculated. Now here again we have to calculate the member forces. So again start with joint A. So taking joint A using method of joints. So we will solve the problem. So let's say this is joint A. Here the forces will come as FAB and FAC. This is theta. And here the horizontal reaction will be -1/2. Okay. Now we will solve this again. We will get summation of horizontal forces to be equal to 0. We will get FAB sine theta plus HA equal to 0. This will give you FAB equal to minus HA upon sine theta. That will give you 1/2 divided by sine 53.13, and from this you will get FAB to be equal to 0.625 kilonewton. Okay. So similarly, we will calculate other force that will give you FAB cos theta plus FAC equal to 0. Now you have to solve for AC. So if you solve for AC, you will get minus FAB cos theta, and you know the value of FAB, that is 0.625, and if you substitute here, you will get the value as minus 0.375 kilonewton. Okay, so what is the third force member that is left? That is FBC. So how we will calculate? We will take joint C. If we take joint C, if this is your joint C, the forces will come FCA and FCB. Here also the angle will be theta. Reactions will also come into picture. Since VC is coming out to be 0, we will not take into consideration. HC will come here. Okay. So now solve the problem, taking summation of horizontal force to be equal to 0. It will give you FCB sine theta plus horizontal force HC to be equal to 0. This will give you FCB equal to minus HC upon sine theta, and it will be equal to 1 by 2 divided by sine 53.13, and in this case you will get FCB to be equal to 0.625 again. Fine. Now we have calculated the forces due to external load. Another thing we have calculated is the forces due to unit load, where we are required to calculate the horizontal deflection. Now we will utilize the principle of virtual work and we will calculate the value of deflection. Okay, so your third question is, you have to determine the absolute horizontal displacement of the truss at joint B. So how we will do? We will make one table which will give you all the details. Okay, so how many members are there? 3 members are there. Member AB, member AC, member BC. 3 members are there. Now I will denote N as the forces we got using unit load. So what are the forces we got? AB equal to 0.625, AC equal to minus 0.375, and BC equal to same as 0.625. Now I will denote capital N to be the forces due to external loads. So in this case, we got capital N to be equal to minus 0.6625. Then this is 40, and this is 66.6625. Okay. I will copy this details and we will solve in next slide. Okay, so okay, now this is fine. Now we have to write what will be the length of the members. So different length of the members are, for AB it is 5, for AC it is 6, and for BC also it is 5. So we have the formula as delta at any point. Suppose I am calculating at B and I am required to calculate horizontal force. So that will be equal to summation N and L upon AE. So now I will calculate the multiplication of N and L. If I will do that, what I will get? Here I will get 208.3203. Here I will get minus 90. And here I will get positive 208.3203. Now, if you do summation of N and L, what you will get? So summation of capital N, small n and L, it will come out to be 90. Now substitute this value in the solution. What you will get? Minus 90, and A and E is provided to you in the question. So your A is 300 mm square and your E is 200 GPa. Now we will make the units to be uniform. So area is 300. We will convert it into meter square. That will come out to be minus 6. Now we will make it in such a way that here the units will be of E will come out to be kilonewton per mm square. Okay, kilonewton per meter square. So this is your 200 into 10 power 9 Newton per meter square. Now since our top one is in kilonewton, I will write it out as 200 into 10 power 6 kilonewton per meter square. So if we solve this, what we will get? We will get as minus 1.5 into 10 power minus 3 meter. So what you will get from this? You will get delta BH equal to minus 1.5 mm. Okay, so this is how you will calculate the deflections at any point using principle of virtual work. So now let's solve this problem again for vertical displacement at another joint, that is joint A. Earlier we have solved this problem for joint B and we have calculated horizontal displacement. Now we will solve the same question and we will try to determine the value of vertical displacement at joint A. So for this, external forces you have already calculated. Now you will calculate internal forces. So for internal forces, you will apply unit load at the point where you are expected to calculate the deflection. So I am applying unit vertical load at joint A, and then again I will calculate the reaction forces. Okay, so in this case, if you take summation of horizontal force to be equal to 0, you will get HA plus HC equal to 0. If you take summation of vertical forces to be equal to 0, you will get VC equal to 1 kilonewton. Okay. Now I will take one joint in which I will take moment equal to 0. So what you will get in this case? You will get HA minus into distance is 6 and no other force is there. That means your HA in this case is 0. So if your HA is 0, then your HC will also be equal to 0. Fine. Now we will solve the problem again and determine the internal forces at different joints using method of joints. So let's draw the free body diagram of joint A. So in this case, you will be having one force here, that is 1 kilonewton force. So if this is A, this is FAC, this is FAB, this is theta, and you have horizontal force equal to 0, so that will not come into picture. So I am taking summation of vertical forces or summation of horizontal force equal to 0. You will get FAB sine theta to be equal to 0 because there is no other force in horizontal direction. That will give you FAB equal to 0. Similarly, if I take summation of vertical force to be equal to 0, what you will get? FAC plus FAB, which is already 0, but I am writing so as for your convenience. And that will become equal to 1. And in this case, you will get FAC equal to 1 kilonewton. Fine till this point. Now we will solve for joint C and we will determine the force member BC. So taking joint C, let's draw the free body diagram of joint C. So if this is your joint C, this will become FCA and this will become FCB. This is your theta, and here vertical reaction was there, that is your VC is coming out. So I will remove this. So your VC in this case was there. Okay. So now let's write the equations of equilibrium. What you will get? Summation of vertical force to be equal to 0. That will give you FCB cos theta plus FCA to be equal to 1. Fine. So in this case, what you will get? Your FBC will become FAC is 1. So 1 minus 1 divided by cos theta. So your FBC will become equal to 0. Okay. Now you have calculated all the member forces. Now we will solve the same problem and we will determine the vertical displacement. So in this case, you have to determine the vertical displacement. So let's solve the vertical displacement. Again, we will make the table that will give you easiness to determine all the forces. So we have three members, AB, AC, and BC. We will first write the internal forces due to unit load. For AB, it was 0. For AC, it was 1. For BC, it was 0. Now we will write capital N. These are the forces due to external loads that will come out to be minus 66.25. This is 40. This is 66.6625. If we write up length, your length are these. Now again we will calculate multiplication of N and L. So in this case, you will get these values. Okay. So this will give you the total multiplication of summation of N and L to be equal to 240. Fine. Okay. Now we will determine deflection at point A due to unit load in vertical direction. That will be equal to summation of N and L upon AE, and that will give you 240 upon 300 into 10 power minus 6 into 200 into 10 power plus 6. Fine. So if we solve this, we'll get the value as 4 into 10 power minus 3 meter, and that will be equal to 4 mm. Okay, so we have determined in this question the values of vertical displacement at joint A and also the horizontal displacement at joint B using unit load method, which is based upon principle of virtual work. Now we will do the same thing for another questions. So in this question, again you have to determine something, either vertical or the horizontal displacement. So in this, it is mentioned we will first calculate it all the external forces. So we will first calculate all the external forces. So in this case, at joint B, you have hinge. So you will be having two reaction. One is horizontal, another is vertical. And at joint A, you have roller support. So you will get only one reaction, that is HA. Now apply equations of equilibrium. Summation of horizontal forces to be equal to 0. You will get HA plus HB to be equal to 5 kilonewton. Fine. Now we have to calculate the vertical forces. So summation of vertical forces to be equal to 0. This will give you VB to be equal to 10 kilonewton. Now we have to take any moment because that is the only option available with us to determine. So if we take moment, what we will get? So let's start with taking moment about point B equal to 0. So in this, minus of HA into 2 and minus of 10 into 1.5 will be equal to 0. That will give you HA equal to 15 upon 2, and this will give you HA equal to minus 7.5 kilonewton. Okay. Now we will calculate the HB. So since HA plus HB is equal to 5, this will give you HB equal to 5 minus of 7.5. That means your HB will come out to be 12.5 kilonewton. Fine. Now we have to calculate the external forces in the member. So how we will start? So we'll start with joint D. Okay. So using method of joints, let's take joint D. So in the joint D, you are having forces. So if this is your D, this will become FDE, this will become FDA, and you have external force equal to 10 kilonewton. So in this case, simply you can determine horizontal force FDA, it will become equal to 0. Okay. And your vertical force will become equal to 10 kilonewton. Fine. Now let's take another joint. We will start with another joint, that is joint A. So if we take joint A, in this case, we are having three forces. And external reactions also, HA. If this is your A, this will become FAB. This will become FAC. And this will become FAD. So now let's take this angle to be equal to theta. So your tan theta will become equal to 1.5 divided by 2. This will give you theta to be tan inverse 0.75, and your theta will become 36.89 degree. Fine. Now we will solve the problem taking summation of forces in horizontal direction to be equal to 0. This will give you FAD plus FAC sine theta to be equal to HA. Okay, this will give you AD, you have already know. So your AD value is, so what is your AD value that you have calculated earlier? So your AD was equal to 0. Okay, now FAC sine 36.89 will become equal to HA. How much you have calculated? It is minus 7.5. So this will give you FAC to be equal to minus 7.5 divided by sine 36.89, and it will be equal to minus 12.5 kilo Newton. So till now, how many forces you have calculated? CD you have calculated, AD you have calculated, AC you have calculated, and AB also we will calculate now. So how AB will be calculated? So we'll take summation of forces in vertical direction to be equal to 0. That will give you FAC cos theta plus FAB to be equal to 0. And from this, if you try to calculate FAB, what you will get? FAB will be equal to 12.5 kilonewton into cos 36.89, and that will become equal to 10 kilonewton. So now we have calculated 4 forces. Only force which is left is BC. So for this, we will take another joint, that is joint B. So let's take joint B. So taking joint B, if I draw the free body diagram, how it will look like. 4 forces are there, 2 are reactions and 2 are the external forces. So that will become FBC. This would be FBA. This would be FBC. This will be HB, and this would be VB. So take summation of horizontal force to be equal to 0. That means your FBC will become equal to HB. And what is your value of HB? So your value of HB is 12.5 kilonewton. Fine. Now you have calculated all the forces. Okay. Now you have calculated all the forces. Now what is required in the question? So question is telling you to determine the vertical displacement at joint D. So now you have to calculate vertical displacement at joint D using unit load method. And how you will do? You will first apply the unit load in vertical direction at joint D. Before that, you will remove all the external forces, and again you will calculate all the internal force in the truss members. So after determining all the forces, we will apply principle of virtual work, and then we will determine the vertical displacement at joint D. Okay, so let's remove all the external forces, and then we will draw the diagram for unit load at point D. So suppose these are your external reactions, okay, at joint B. So that will become HB and VB. This is your B, this is your C. Here also one reaction will come, that is HA. So suppose this is your HA, and now at joint D you will apply 1 kilonewton of vertical displacement. Okay, now we will again solve the problem and determine all the internal forces. So what we will do, we will again we'll first calculate the reaction forces. So how we will do that? We will take summation of horizontal forces to be equal to 0. That means your VA plus VB, sorry, HA plus HB to be equal to 0. And if we take summation of vertical forces to be equal to 0, you will get VB equal to 1 kilonewton easily. Fine. Now, third equation that we will utilize is taking summation of moment about point B to be equal to 0. If we utilize that, we will get horizontal force in the anti-clockwise direction and 1 kilonewton load also in the anti-clockwise direction. This will give you HA equal to minus 1.5 divided by 2 equal to minus 0.75 kilonewton. Right? And you already have HA plus HC equal to 0 or HB equal to 0. This will give you HB to be equal to plus 0.75 kilonewton. Now, external forces we have calculated, or external reactions we have calculated. Now we will determine all the forces. So start with joint D. If we take joint D, so apply method of joint principle. Three forces are there. One is unit load and two are internal forces, FDC and FDA. In this, if we take summation of horizontal force to be equal to 0, what you will get? FDA to be equal to 0. Now take summation of vertical force to be equal to 0. What you will get? You will get FDC to be equal to 1 kilonewton. Now we will take joint B and we will solve this problem. So let's take joint B. In joint B, you will be having four forces. Two are reactions, that is VB and HB, and two are internal forces, that is VBA and VBC. So in this case, your summation of horizontal force, if it is equal to 0, that means your FBC is equal to HB. And how much HB you have calculated? Your HB is 0.75 kilonewton. Now if you take summation of vertical force to be equal to 0, you will get FBA equal to VB, and your VB in this case is 1 kilonewton. Fine. So 1, 2, 3, 4 forces we have already calculated. Now we will take joint C and we will calculate the force AC. Fine, no? So in this case, this is your FCB, this would be your FCA, this would be your FCD, and your theta in this case will come in this point. Okay, now you will take summation of horizontal force or summation of vertical force will take equal to 0. So what we will get? We will get FCA cos theta plus FCD to be equal to 0. FCD we already know. So from this we will calculate FCA equal to minus of 1 upon cos theta. That will come out to be minus 1.25 kilonewton. Now we have calculated all the forces due to unit load. Now what we will do? We will determine the vertical displacement at joint D. Fine. So how we will do? We will draw the table and then determine the value using principle of virtual word. So let me write here all the member forces. So how many members are there? So total 5 members are there. AB, BC, CD, CA, and which one is left is DA. So due to internal forces or due to unit load, what are the forces comes out to be in the members are these. Now due to external forces, what are the values of force we got are these. Now I will write different lengths of the members. So for AB it is 2, then it is 1.5 to 2.5, and then 1.5. How CA is 1.5? So CA will be equal to 2 square plus 1.5 square, having under root, that will come out to be 2.5. Fine. Now let's determine all these values. So I will paste this table here, and now I have to determine N and L. So what will come? In this line, it will 20. In next line, for BC, it will come out to be 14.0625. For CD, it is 20. For CA, it would be 39.0625. And for DA, it would be 0. Now taking summation of all these values, what we will get? So if we take summation of N and L, it is coming out to be equal to 93.125. Now you will determine the vertical deflection at joint D. So vertical deflection at joint D will be equal to summation of N and L upon AE. In this case, N and L upon N and L come out to be 93.125. A we have calculated, A is given out to be 400 mm and E is 200 GPa. So we are writing, this will be 6. So it will be 6, and in this it is GPa, so it will come out to be plus 6. And if we solve this, what we will get? We will get 1.164 into 10 power minus 3 meter. So that will give you delta deflection at point D in vertical direction to be equal to 1.164 mm. Fine. So this is how we will solve the problems related to principle of virtual work, and we will calculate the deflections at different points. So let's solve one more problem. Okay. In this truss also, you have to find first all the external forces. So let's solve that. So here you have hinge. So two reactions will come. So I will write so I will make, so this is your VD, this is your HD, here also HC, and one VC. Fine. Now let's solve this problem. So take summation of vertical force to be equal to 0. What you will get? VC plus VD to be equal to how much? 50. Now you must be thinking that in this truss is not a determinate truss, because in this degree of indeterminacy is coming out to be 1. But the problem is, in this you can determine one reaction directly using method of joints. So let me give you a glimpse for regarding that. So since here you have two vertical reactions and two horizontal reactions, that means your degree of indeterminacy is coming out to be 1. But how you will determine the unknown force? You will take joint D, and at joint D you will apply method of joints, and from that one equation you will be eliminating. That is, your VD will come out to be equal to 0. So let me write, and then you will be able to see that. Okay. So in this, if you write summation of horizontal force to be equal to 0, you will get HC plus HD to be equal to how much? Equal to 0. Now, if we take any moment, suppose I am taking moment about point D equal to 0. So what you will get? You will get minus of HC into, what is the distance? 2, minus of 20 into 1.5 and minus of 30 into 3. It will be equal to 0. And from this, if you try to calculate HC, you will get it as minus 60 kilonewton. Okay. HC if you have calculated, then you can calculate HD also. So your HD will come out to be equal to plus 60 kilonewton. Now, if we take another joint, like suppose MA equal to 0, in this case, what you will get? You will get 20 into 1.5 plus or minus VC into 3 minus VD into 3 plus HD into 2 equal to 0. Now, VC and VD are unknown for you, but we write it as VC plus VD, and that will become equal to 30 plus 120, and that will give you VC plus VD again as 50. So that means now you are left with no option to calculate these unknown values of VC and VD. So how we will solve this? We'll take joint D. So using method of joints, we will take joint D first. So if we take joint D, in this case, you can see here 4 reactions are coming, or 3 reactions are coming, not 4. So if you mark it, so if this is your D, this will become FDE, and your HD came out to be 60 kilonewton, and your VD you have to calculate. Now take summation of vertical force to be equal to 0. That will give you VD to be equal to 0. So if your VD is coming out to be equal to 0, then this implies your VC will be equal to 50 kilonewton. Okay. Okay, so don't judge this problem based upon the degree of indeterminacy. You have one another equation based upon method of joints. Now we have calculated VD. Now let's solve for the problem and calculate different member forces. So in this, if we take summation of horizontal force to be equal to 0, this will give you FDE to be equal to 60 kilonewton. Okay. Now next joint we have to take is joint C. So if we take joint C, so how many forces are coming here? So this will be your VC. This will be your HC. What is the value of VC? VC is 50. HC we have calculated it to be minus 60. This would be your FCE. This would be FCB. Let's say this angle to be theta. So now tan theta will be equal to 2 upon 1.5. This will give you theta equal to tan inverse 2 upon 1.5 equal to 53.13 degree. Now take summation of vertical force to be equal to 0. That will give you FCE sine theta plus VC to be equal to 0. From this, you can calculate FCE equal to minus of VC, that is minus of 50 divided by sine theta, and it will come out to be minus 62.5 kilonewton. Now if you take summation of horizontal force to be equal to 0, so what you will get? You will get FCE cos theta plus FCB to be equal to HC. From this, you can calculate FCB to be equal to HC is minus 60. FC is minus plus will come out to be plus 62.5 cos theta. Substitute the value of cos theta. You will get FCB to be equal to minus 22.5 kilonewton. Fine. Now let's take joint B. So if I will take joint B, so in this case, you will be having three forces: VBA, VBC, and VBE. From this, you can easily see that VBE will come out to be 0. How? By using summation of vertical force to be equal to 0. And if you take summation of horizontal force, that will give you VBA to be equal to VBC, and VBC you have already calculated as minus 22.5 kilonewton. Now take one more joint, that is joint A. If you take joint A, in this case, you are having FAE, FAB. Vertical force here is 30 kilonewton, and theta you have already calculated. So take here summation of vertical force to be equal to 0. That will give you FAE sine theta to be equal to 30. From this, you can calculate FAE equal to 30 upon sine 53.13. And if you substitute the value, you will get the value of FAE equal to 37.5 kilonewton. Now you have calculated all the forces in the members due to external loads. Now next question is telling you that you have to apply you have to find the vertical displacement at joint A using unit load method. So how you will solve this? You will apply unit load at joint A, removing all the external loads. Okay, so let's draw the diagram first. So if we draw the diagram something looks like this. Now I will apply unit load. Okay, so if I will take VA and HD as a reaction at point D, and VC and HC as reaction at point C. Let's mark the diagram first. Now, if we calculate all the values of reactions, so what we will get? Let me copy this diagram and I will paste it here. Now let's determine the value of external forces. So we'll start with summation of vertical forces to be equal to 0. So from this we will get VC plus VD to be equal to 1. If we take summation of horizontal forces to be equal to 0, we will get HC plus HD to be equal to 0. Okay. Now if we take moment about point D, what you will get? You will get minus of HC into 2 and unit load into distance 3. That will give you HC equal to minus 1.5 kilonewton. So if HC is minus 1.5, then this will give you HD to be positive 1.5 kilonewton. Fine. Now vertical forces, since you already know, we cannot calculate using this. Now what we will do? We will take joint, that is joint D, and then we will solve the problem. Okay. Now if we take the joint D, in joint D, let's draw the free body diagram of joint D. In this, if it is FDE, this is your VD, this is your HD. Okay. So your VD will come out to be equal to 0. This implies your VC will be equal to 1. Right? Now we will determine the forces at different joints. So how we will do? We'll determine using summation of horizontal force to be equal to 0. From this we will get FDE equal to HD, and HD we have already calculated as 1.5 kilonewton. Now let's take another joint. Now I will be taking joint C. So if I take joint C, So you have VC, HC, and the force members, that is FCE and FCB. This is your theta angle. Okay. Now take summation of vertical force to be equal to 0. This will give you FCE sine theta plus VC to be equal to 0. If you substitute the value, you will get FCE to be equal to minus 1 upon sine theta, and from this FCE will come out to be minus 1.25 kilonewton. Now let's solve for FCB. So if I solve for FCB, what I will get? So taking summation of horizontal force to be equal to 0. So we will get FCE cos theta plus FCB to be equal to HC. Now your FCB will come out to be, HC is minus 1.5, and you have other forces, that is 1.25 cos theta, and that will come out to be equal to minus 0.75 kilonewton. Anyone has any doubt? I thought someone has writing in comments. Let me see. So I'm missing something at joint B. Can you explain at which point? Sudhir Kumar, can you explain where at joint B I have missed? Have I missed anything? Okay, thank you. Okay, so you are telling like I have missed this force. Okay, yeah. So here in vertical force I have missed to be 20 kilonewton. Okay. Okay, thank you Sudhir Kumar. So that means your FBE will be 20 kilonewton. Fine. Okay, so let's continue. So where we are, so in this we have calculated FCB. Now we will take another joint, that is joint B. So if we take joint B, now no external reaction will come. Okay, now we can take as 0. So at joint B, this would be FBA, this would be FBC, and this would be FBE. So here we can take summation of vertical forces to be equal to 0. So that will give you FBE equal to 0, because in this case we are not taking external forces, because we are taking the loads due to unit force that is applied at joint A. So here summation of horizontal force FBA will come out to be FBC, and FBC we have already calculated equal to minus 0.75 kilonewton. So last joint that we have to take is joint A. So if we take joint A, so at joint A, this would be 1 kilonewton, this would be, I think so, FAE and FAB. So FAE and FAB. This would be theta. So if we take summation of vertical force to be equal to 0, that will give you FAE sine theta equal to 1, and from this FAE will be equal to 1 upon sine 53.13, and that would be equal to 1.25 kilonewton. Now you have calculated all the forces due to external force as well as due to internal force. Now we will apply principle of virtual work, and then we will determine the vertical displacement at joint A. Fine. So let's make the table. I will make in next sheet. Okay. So in this, I will write all the members first. So how many members are there? AB, BC, CE. Then we have EA. Then we have ED. And one more member is there, that is BE. Now I will write all the forces due to unit load. It would be minus 0.75 ED is 1.5 and B is 0. Now all the forces due to external load, it will come out to be minus 22.5, minus 22.5, minus 62.5, then 37.5, 60, 20. Now write different length of the members. So L would be 1.5, 1.5. CE we have already calculated to be 2.5, or you can calculate here also 2.5. EA will also be same as 2.5. ED is 1.5 and BE is 2. Now do the multiplication for N and L. What you will get? So here you will get 25.3125. Next also you will get the same 25.3125. Then you will get 195.3125, 117.1875. Next would be 135, and then it would be 0. If we do summation for this, what you will get? So summation of N and L, it will become equal to 498.125. Okay. Now we will determine the vertical reaction at point A. It will be equal to summation of N and L upon AE. N and L you have already calculated as 48.125, 498.125 divided by area of cross section. Area of cross section in this case is 400 mm square. We'll convert it into meter. Then you have 200 GPa as the value of unit modulus, and we will convert into kPa. Okay. So by this you will get the value as 6.2266 into 10 power minus 3 meter. That will give you vertical deflection at point A due to unit load, or vertical deflection, it will be equal to mm. Fine. So I think by all these examples you will be able to determine how to determine the vertical deflection or horizontal deflection at any joint in the truss member using principle of virtual work. So how to utilize principle of virtual work? You have 5 steps available. First, determine all the member forces in the truss that is available. So how you will determine? First, determine all the external reactions and then determine all the forces in the truss member due to external loads. After determining this, whichever joint where you are expected to calculate the vertical or the horizontal deformation or deflection, apply a unit load in that direction in which you are expected to calculate the deflection. That means if you are expected to calculate horizontal deflection, apply a unit load in horizontal direction. And if you are expected to calculate vertical deflection, then apply a vertical load in vertical direction. Then remove all the external forces, determine the value of internal forces that is now coming in the truss member. After that, use principle of virtual word and then determine the value of horizontal or the vertical deflection using the formula provided to you. So anyone has any doubt? So this week we have covered the problems related to principle of virtual word, and we have solved all the problems related to trusses. From the next week, we will try to solve the problems related to beams as well as frames. So if no one has any doubt, so let's wrap up this session. Thank you, everyone. Have a nice day. Enjoy your weekend. Let's close.